All set? Here we go. The problem we are about to attempt today is a bit tough. Let me make it very clear that this is going to take some time, maybe the next 20 to 30 minutes. This has been sent to me by Rasik, and they got this problem for their assignments, and he had requested me that sir isko bana ke zara bata dijiye. So I'll give you a complete demonstration, a step-by-step demonstration as to how you can make the isometric view of this orthographic projection of an object. Now, first of all, whenever you are attempting problems based on isometric drawings, listen to this carefully. Please note, the problem description may ask you to create an isometric projection or an isometric view. What is the difference? Both of them are isometric drawings. However, please note, when you've been asked to make an isometric view, it is done with the help of true dimension. For example, in this drawing which I have already prepared, by the way, this is the final solution. Okay, I'll erase it, and I am going to draw it right from the scratch. Okay, so I was talking about isometric view. If you've been asked to make the isometric view, please note that the true dimension of 47 is represented here also in the isometric view. Basically, it is created using the true dimensions only. However, if you have to draw isometric projection, we use a factor, a reduction factor or a reducing scale whose magnitude is 0.62. Okay, you can draw an isometric scale also. You can simplify, multiply the actual dimension with 0.82 to get the isometric corresponding isometric dimension, right? So in 99% of the problems I have come across, I've seen that professors have asked students to create an isometric view. Okay, that's the first thing. I also have made a CAD model of this object. Take a look. This is the isometric view, the final solution. This is how the object looks like. Take a look. So there is a deep cut throughout the thickness of the object, and then there is this slope that you have to encounter. This is how the object looks like, and there are different isometric options. Let me just show this to you. This is one way. This is basically southwest isometric. This is one more option of southeast isometric. Whichever way. If you are drawing this as your isometric view, right? If you draw this as your isometric view, your front is going to be from over here. You can see this box. However, if you are making this as your isometric view, your front is going to be from over here. So place an arrow once you are done with your isometric view. Done? Okay. One more thing that I would like to bring to your notice is, let me switch off the scrolling text. We now are in the layout tab. This is the model space. This is the layout space. Right click on it. Go to page setup manager. And here, I think I have already done this. This is A2. This has been set to A2. You can go for A3, A4, whatever size suits your drawing. Let me click on OK. One more thing that you need to check is right click on this. And by the way, you are also learning some of your, you are also enhancing your AutoCAD skills by watching this video. Okay. And if you are making this drawing manually, follow the instructions. You will be able to do it without any hiccups. Let me be very honest with you. Go to drafting standard setup and check if it is set to first angle projection or not. Yes, it is. Okay. If you're handling an American client, you have to go for third angle projection. Okay. Now let's click on this ribbon layout base from model space. Click. I want to see the hidden lines. One more pops up, shaded with hidden lines. And yes, that's it. Enter and then click. Again, you have two options for isometric. Either you can go with this option or you can go with this option. Which one do you wish to create? I think for today's class, we are going to be creating this as our isometric view. अरे भाई कहाँ चला गया? अभी तो बनाया था. From model space. Click. Hidden lines. Shaded and hidden lines. Enter. Click. 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 Yeah, we are done. Enter. Once you hit enter, you are out of the command. Right? This is what we are going to prepare. By the way, we are not going to be showing the hidden lines. So let me just click on this, go for edit view, and not shaded, only visible lines. This is what we are going to prepare. What I want you guys to do, okay, this is going to be my way, this is going to be my front on. What I want you all to do is you have to make your isometric view like this. Let me click here, let me go for edit view, let me go for visible lines. This is what I expect you guys to prepare. If you are doing this on AutoCAD, follow all the instructions. Even if you are doing it manually on a plain piece of paper, you can implement this by following all the instructions step by step, which I am about to give. Okay, now let's move on. First of all, let's erase. And whenever we start any problem on isometric, I think the best practice is to check out what the overall length, width, and height is. If you watch carefully, the length is 107, the width is 48. So let us make the base first of all 107 by 48. So one more thing. How can I forget this? Whenever you're drawing an isometric view or any isometric drawing, make sure, and by the way, if you're following this on AutoCAD, make sure that this button is on. Okay, this polar tracking F10 is on. You have to set it to this 30, 60, 90 mode. We are always going to move in a 30-degree manner with respect to the horizontal, right? Let me just show this to you this way. Either we are going to move in this fashion, or in this fashion, or in this fashion. This is how you are going to draw lines, either this way or this way or in the vertical fashion. Please draw this, and please note, let me, at this angle over here, DMANG, click, enter, click, enter. Okay, so these are the three isometric axes. The angle between all of them is 120 degrees, 90 plus 30, 90 plus 30, and this angle over here, 180 minus 60, will give you 120 degrees. So all the angles are equal. That's why equal is iso in Greek, therefore isometric, right? So let me erase this. But for all the guys who are doing it manually, you have to make this. Okay, so far so good. So let me first of all start by making a line of 107. So this in orthographic is a straight horizontal line, but in isometric it will be at an angle of 30 degrees. How much? The length happens to be, the length by the way is 107, and enter. Then you have to make this width of 48. So this again 48, enter, and here back 107, and you can close it now. So the base of the object has been made, right? We are going to now create a box inside which we'll be fitting this object, right? So what is the height? Maximum height I'm talking about. It is equal to 47. So give it some height, 47. 47, enter. Now click on this, make a copy. This is the base point. Click. Now select these, and for all you guys who are doing this manually, you can join all of these points. Okay, the rest of the guys doing in AutoCAD can follow the copy command. And by the way, the world is going to change big time. As someone who is a mechanical, civil, or an electrical engineer, it will be expected from you that you first of all need to have some very good drawing skills. You should be able to interpret the drawings correctly. It could be a production drawing or a manufacturing drawing. You should be able to interpret it. It will also be expected that you can design an object. You should have good skills. Yes, you should have skills of drawing the views of an object manually. However, it will be expected from you that you should be able to do it on a virtual environment, which is AutoCAD. So please pay attention. Okay, take this very, very seriously. If you are from a core engineering discipline. AutoCAD is like the ABCD, okay, of the CAD world. So if you can understand the AutoCAD's interface, you should be able to understand the interface of higher end softwares like SolidWorks. And where SolidWorks ends, CATIA begins. Okay, so this is how you go up the tree. Anyway, so this is what we've done. Now the idea is, or in most of the cases, what I have done is I start by creating this top view at the bottom. When I say at the bottom, I mean to say here. Look at this portion that I've selected. I will create the top view, and one by one I'll give all the points at the bottom some height by looking at the front view. This is one approach. The other approach is to start by creating the front view. Now, if you're planning to create the front view, you have to select this plane. Okay, this entire front view can be created over here. Check it out. And this is what we'll do. So follow the instructions. Take a look at this very point. That is in orthographic. Same point, it is in the isometric. And by the way, I want to get rid of all of these lines. I don't want to confuse my students. Neither do I want to confuse myself. Okay, take a look. To the right, a distance of 56.5. 56.5. And one more thing, let me make this very, very light. You can decrease the transparency. By the way, you just can simply click on it. If you have not set up the layers, you can simply click on it, go to properties, and then you can increase the transparency. The option for transparency is here, right? Okay. By the way, it is always advisable to set up the layers initially and then start with your drawings. As you can see, I have made several layers. Layers for construction line, layers for hidden lines, and then solid thick lines, different colors I have. Okay, I can switch on and off any layer. As you can see, this is now a part of the construction line. If I switch it off, it will be off. I can switch it on. Okay. Okay, so now what? What can we do now? Okay, 56.5. And by the way, I think it would be better if I can keep it closer. 56.5. 0.5. Done. This is 35. Downwards, 35. 35, 35. Done. This is 60 millimeters. Again, please note that I'm always moving at a certain slopey angle of 30 degrees. Okay, this is 60 millimeters, and enter again, you are out of the command. If you hit enter back, you are inside the command. Which command? The previous one. That is the line command. You need to go downwards. The folks who are doing it with pencil, they can stop right here. I'll go beyond it, and because I have a trim command, TR, double enter and click, and you are out of it. Now see this line in isometric is this one. Now what? Now there is an issue, sir. What is the issue? The issue is this is the true angle. Okay, so far we have been shifting the dimensions from the orthographic to the isometric. That is okay, but how do you shift an angle of 30 degree from orthographic into an isometric? This is going to be a problem for us. What we'll do is can you see this triangle over here? An imaginary triangle. Yes sir, we can see this. What is the angle? Sir, it is 30 degrees. So I'm going to create a triangle over here, and it is the reference of that triangle. I am going to locate this point. Wait, don't worry. Secondly, how much is this distance? Sir, this can be calculated. How? Sir, we've got this distance as 107 minus 56.5 will give us this distance. Okay, so do we have a calculator? Yes, we do have it. 107 minus 56.5, 56.5 and enter. So this distance is 101 by 2. By the way, if you have a careful look, if this is x plus x, that is 2x, is equal to 50.5. How much? 50.5. So what did I do? No. Why did I divide it by 2? It is not needed. What are we calculating? We are simply calculating this is 107, this is 56.5. Let me do the calculation again. 107 minus 56.5, and here we go. This is equal to 50.5. So this distance is 50.5. So 50.5, and then at an angle of 30 degree, you can draw this line. I think we are good to 50.5. Let me start. 50.5. And one more thing, draw a line over here at an angle of 30 degrees. So this has been drawn. And then you can simply draw this vertical line wherever it intersects. Okay, there you go. You have the triangle. Trim it. And if you have any doubts, please check that the angle over here is 30 degrees. And one more thing, that the distance over here, we took it as 50.5. So 50.5 plus 56.5 will give you 107,107. I hope that I have made myself absolutely clear. Can we move ahead? Okay. But sir, you still haven't explained how you are going to find this point. We know that there is a point over here. How high is it? We don't know. Or how much below is it with respect to this horizontal line? We don't know. Yes, we do know. Take a look. This is how much below it is. Okay. So you have to, if you're doing it manually, you can keep one leg of your compass at this very point, the other leg over here, and then you can make an arc. If you're doing this on AutoCAD, I would strongly recommend you using the circle command. C, shortcut for circle, enter, center, and click, move. With respect to center, move it over here. This is how you take the references and put the arcs, right? A, enter, C, enter. You don't have to worry about this. What you can also do is use the break command. Click. This is the arc. Now you understood. Okay. Now you simply need to join. You need to join over here. If you can't find this point, hold shift, right click, intersection, and you will see a cross. Once you see the cross, that is the intersection. Click on it and bang, you have joined it. Now you get rid of this. And for folks who are doing it manually, you have to cut an arc. You will get an intersection. That intersection point, you can join it with over here. So far so good. And now let me also join these two. Okay. How do we proceed from here? First of all, allow me to shift this. Looks good. Okay. What is this? 24 plus 24? 48. That is the width of the object. So now we are going to fit the width. Check this out. Again, at a specific angle, 48, enter. Now let me copy this. For students who are doing it manually, you have to make these lines. I mean, it would be best to keep your drafter at this angle, set it up, lock the screw, and then move it to this point. And then draw a line, this point, draw a line, this point, draw a line, draw a line. Keep on repeating this. I think there is something which is remaining. We are yet to make this portion. How far is this line? Sir, this line is to the left of the rightmost corner by a distance of 22. So what we'll do is, at a distance of 22, come to the left, 22, and then go straight upwards. Kidhar gaya bhai? Here is a line command. L, enter. This way, 22 millimeters, enter, and then straight up, enter. Wherever it intersects, TR, double enter, cut this, chip off this portion. This is what you need. Okay. I think it would be better if we can just draw a line from this very point also. I would strongly recommend this. देखिए थोड़ा सा गड़बड़ हुआ. Move it. move it, fix it. Now it's perfect now. Okay. Okay, sir. So the front view is complete. Where have you made the front view? In the front plane, on the front plane. Let us take a look at both the views simultaneously. Check this out. We are here. There is physically no object over here. However, we have made lines. Don't worry. We are going to use it as a reference point. This distance is 22, which we have already fit. This is 22. Yes, agreed? Okay. This is 13 millimeters. If this is 13 millimeters, this is also 13 millimeters. Agreed? Okay. So what we'll do is, and by the way, one more thing that I forgot. Please, let me finish this. All of these points have to be joined. Guys who are doing it manually, bhai, pura khichna padega. You have no other option. You have to connect all of those points one by one using a pencil and a scale. Right? Okay. Now, I think it would be best for now to get rid of these lines because it creates a lot of confusion. Okay. Yeah, that's good. In fact, keep it till here. Only this much portion of the edge would be visible. Remaining portion won't be visible. We won't be showing it. Right? We are under no obligation to show the hidden lines. Right? Okay. Now what? Kya kare? 22. This has been fixed. 22. This is 13. This is 13. Here. Check this out. 13 millimeters. 1, 3, enter. Can you see this? This distance over here is 13 millimeters. 13. Similarly, this is 13. Right? Now what to do? Take this as your reference. This as your reference. And for students who are doing it manually, you can simply draw a line from over. Where is that point gone? Here it is. Here it is. Okay. Looking nice. Now we have to give the front portion some final touches. This distance will be same. Copy. Yeah. This distance, the same length will be reflected below this very point. And now you can simply connect all of these this way. Right? You in fact don't need these two lines. In fact, you only have to draw this much only. Only this much portion of the edge would be visible. If you want, you can remove these lines. Okay. So far, so good. In fact, I would suggest you to remove this portion also, and this portion, and this portion, and this portion, and this portion. Yeah. In fact, remove this portion, this one. Yes. Remove it. Chip it. Yeah. So this profile is it's very clear now. Let me remove this portion and now try to match what I have just made. Try to match how the object would look from the top, isn't it? This portion. This is how it would look. Right? Now we come to the part where we are going to create this profile. I want all of you to pay attention. There are two centers. One center is over here and one over here, and hence in order to represent those centers, we have used a center line. long dash followed by a dot, long dash followed by a dot, sometimes a line also, small line in fact. Here also these are those two centers are represented in the front view. The distance between the two centers is 22. If you subtract 22 from 56.5, what do you have? 56.5 minus 22. This is what you have, 69 by 2, that is 34.5. So this x plus x, that is 2x, will be equal to 34.5. X will be equal to 34.5 divided by 2, which will give the value as 17.25. So essentially this is 17.25 and this is 17.25. This is 17.25 and this is 24. This is 24, this is 17.25, either way. Okay, so we want to reach this center. Once we reach here, we can easily create this semicircle followed by a rectangle. Once you make the rectangle, again you have to make this semicircular profile. Once that is done, your isometric drawing is done. 17.25. Please remember, how much? 17 from, so this center over here, 24. I can locate this center and you have to move by a distance of 17.25. I don't know who made this problem, but my recommendation, I mean 17.25 can be inputted very easily with the help of in this virtual environment. However, if you're doing this manually on a drawing sheet, 17.25 millimeters is rather impossible. You can't do it accurately, right? Anyway, so we are here. If you watch, this circle has a radius of 8. So 8 to the top, 8 to the left, 8 to the bottom. Okay, we are going to create this. Basically can be inscribed a circle, a square. So the isometric view of a circle can be made here. And let me just start this. 8 this way, 8 this way, 8 this way, 8 this way. In fact, I would get rid of this line. Please note, this distance is 17.25 and this distance is 24. So 24, 17.25, or you can also go in this fashion, 17.25 and then 24 this way. You are going to reach the same destination. Okay, now what? Watch. For those who are doing it on AutoCAD, you can simply select them, copy, copy. And for those who are doing it manually, set your drafters along this line, tighten the screw, then move it to this point, draw a line, move it to this point, draw a line. Follow the same steps for this profile also. This way and this way. Done. Now, larger diagonal, smaller diagonal. Where are we? From which end point of diagonal do we start making lines from? We do it from over here. That is from the smaller diagonals. These are the two midpoints in front. Draw these lines. These lines. And as we know that we have to make a semicircle this way. So one of the centers is going to be this. This way. You use a compass. Use a rounder. Keep one leg, steel end over here, pencil end over here, then draw that. Take this as the center. Always in an anti-clockwise sense. Okay, so this is done. Now I would select all of them. Now I would deselect this arc and also this point, and I'll erase the rest. Now from here, take a look. This is the point I want all of you to focus on. This is the point. From here we are going to move towards the right, and the distance is 22, which is reflecting in the front view. 22. From here, 22 millimeters. 22. Done. Now the same construction, we have to go for this semicircle in the same fashion. So you make this line. Let me zoom in. 8 millimeters, 8, enter, again 8, enter, copy. Manual drafters can use mini drafter, copy, paste point, enter, enter. There you go. Smaller diagonal, always go for smaller diagonals. Start by making a line from this way, this way, and this way, and this way. Now this is going to be the arc that we're interested in. Arc. One center is over here. Again, one center is over here, and we are done. Now you can select and keep this, get rid of the remaining. Right, we are almost done, students, almost done. In order to see the depth, what we can do is, this is sort of a circular profile. In fact, the plane over here will be curved semicircularly. I don't know if that is a word. This is a flat surface. So wherever these two surfaces meet, that means over here, you have to go for this line. Similarly, this is a flat surface, this is a curved surface, they meet somewhere here, this is the interface. So again, you have to draw a line through this very point also. Now, like, one sec, I think this point. Okay, TR, double enter, chip of this portion and this portion. Only this is going to be visible. I think I have already shown this to you in the drawing also. Can you see this? This is the isometric drawing created by the computer, AutoCAD. Okay, I would strongly suggest all of you to make the isometric view from this orientation. This is going to be your front. Please place an arrow and write front over here. Please place an arrow over here, write top. And for this very isometric view, place an arrow. This is for front, place an arrow, this is for top. This is how you are going to do it. Z, enter, A, enter. Okay, so this is what you have to do. So with this, we conclude another example on isometric projections. Okay, this is a case of isometric view rather. If you got any problems on any topic on engineering drawing, you can write down in the comment section. If you are hesitant, if you are reluctant, email it to me. Okay, manas2787@gmail.com. That is my email address. Send it to me and I'll make sure that I'll make a video on it as soon as possible. Okay, so guys, yes, that was all from my side. And by the way, if you want to learn some serious engineering drawing and engineering mechanics and AutoCAD stuff, to download my application, the link for which can be found in the description down below. And yes, that would be all from my side for today. If you've got any doubts or queries, write them down in the comment section. And if you are still with me, we are almost 33 minutes into the video. If you're still with me, do give it this video a like and share it with as many friends as you can. This is Manas Patnaik signing off. Take care and have a nice day.